Okay, in chapter 2, we are going to be working with quadratic functions, which we've seen before. So for day 1, we're going to review transformations of quadratic functions. Okay, as a reminder, quadratic function is degree 2. When it's in standard form, it's y equals ax squared plus bx plus c. Vertex form is y equals a times x minus a squared plus k, where hk is the vertex. A indicates if there's a stretch or a shrink or a reflection. Okay, and then the graph is a parabola. So let's do the parent function. The parent function of a parabola, 0, 0, because 0 squared is 0. 1 squared is 1, so 1, 1. Negative 1, 1. And then 2, 1, 2, 3, 4, 2, 4, because 2 squared is 4. Negative 2 squared is also 4. Okay, and then we draw the shape. It should be a U shape. So it should curve, unlike the parabola, not the parabola, the absolute value, which were a V. Okay, so for our first example, we're just going to identify the information of the graphed parabola. So if I look at this picture over here, the vertex is right there. That should be an ordered pair. It's 1, 2, 3, comma, negative 1, negative 2, negative 3, negative 4. So 3, negative 4. Okay, the axis of symmetry divides the parabola into two symmetric halves. I'm going to make it a dashed line because it's not part of the graph. It just helps identify the information. So it looks like this. It's a vertical line, so the equation of the axis of symmetry has to start with x equals, in this case, x equals 1, 2, 3. So it's x equals 3. Or you could figure out what x equals based on the vertex because it will always match right there. Okay, now let's look at the graph for the x-intercepts. Okay, this is the x-axis. So there are two x-intercepts on this particular parabola. One is here. What is that? That's 1, 0. There's also one over here, which is 1, 2, 3, 4, 5, 0. So 1, 0, and 5, 0. Okay, and then the y-intercept, this is the y-axis, so the y-intercept is up here. And that's 0, comma 1, 2, 3, 4, 5. So 0, 5. Okay, so if I refer to any of these pieces of information, you should be able to tell what I'm talking about. Okay, let's transform some and then graph them based on the parent graph. So identify the transformations of f of x equals x squared. These are all parabolas, and then I'm going to graph g of x. Since it's asking me to identify the transformations, I am going to list them too. Okay, so what do I have? I have parentheses x plus 2, so that's going to go left 2. And then we're subtracting 4, so down 4. Hold on, I spelled left wrong. Okay, so normally the vertex is 0, 0. Let's go left 2, down 4. 1, 2, 3, 4. My new vertex is down here. And then it should make the same shape as the parent graph. So I'm going to go right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. If you want to go further, you could go right 3, up 9, because 3 squared is 9. Okay, and it should look curved. Don't make it look like a V. That's absolute value. Let's look at the next one. Okay, what do we see on here? Well, there's a negative in the front. What does that do? Reflect x-axis. So it's going to open down. What else? Right 4. Okay, so if I go right 4, the vertex is over here. Since it's reflecting the axis, it's going to open down. 1, 2, 1, 1, 2, 1, 2, 3, 4, 2, 3. Okay, let me sketch the parabola. Okay, let's try C. G of x equals 3x squared. So the only thing different is the 3. If I times 3, it's going to be stretched. So this is a vertical stretch by 3. Okay, the vertex stays at 0, 0, though, because that's the only thing that happens. Instead of going right 1, up 1, I'm going to go right 1, up 3, because a vertical stretch stretches the y value by 3. Left 1, up 3. I'm not going to go right 2, up 4, because I would have to go right 2, up 12, which is going to go way off my graph. So this is my vertical stretch. 3 times as high. Okay, one more. Okay, we have a lot going on here. Let's see, there's a negative. So reflect x-axis. Okay, there. Also a 2, so this is a vertical stretch. by 2. And then we have x plus 1, so it's going left 1, and it's going up 5. So let's move our vertex first. It goes left 1, up 5, so it's way up here. Reflects the x-axis, so it's opening down and it's stretching by 2. So I'm going to go right 1, down 2. And then normally I would go right 2, down 4, but it's stretched by 2, so I need to go right 2, down 4 twice. 1, 2, 3, 4, 1, 2, 3, 4, which is way down here. 1, 2, 3, 4, 5, 6, 7, 8, and then same on the other side. Okay, so I have a parabola. It's stretched twice as far. It's opening down, and it went left 1, up 5. Okay, for the next example, they've given us a graphed parabola, and they want us to come up with the equation of the function. They don't tell us what to call it, so you could do y equals f of x equals whatever you would like. Let's look at this. What is this going? This is going left 1, down 3. So let's start with that. Left 1, it's a parabola, down 3. It's opening up. Is there a stretch? And see from here, I go right 1, up 2. So this is actually stretched by 2. Let's look at the next one. Okay, y equals. It's definitely opening down, so I know there's going to be a negative. Okay, now what happened to the vertex? It went right 3, 1, 2, 3, up 2. Right 3, up 2. Is there a stretch? From the vertex to the next point, it's 1, 1. So there's no stretch, but it does open down, so I put the negative sign. Okay, one more. Y equals, let's see, where's the vertex? The vertex is right here. It goes up 1, 2, 3, 4, 5, up 5. Okay, and it's opening down for sure. Is there a stretch? Okay, vertex to the next point is here. So that's going right 1, down 1, 2, 3, down 3. So this is actually negative 3 x squared plus 5. Went up 5, opens down, stretch of 3. Okay, last example, let's write the equation for the functions with the indicated transformations. So what does it say? The graph of g is a vertical stretch by a factor of 3 followed by a translation 1 unit right of the graph of f of x equals x squared. So let's start with this thing. Okay, and then I'm going to go in order. So first thing I'm going to do is I'm going to stretch by 3. So this is going to make it 3x squared. Okay, then what am I going to do? Followed by a translation 1 unit right. Okay, so that's the 3 is going to stay there. I'm going to move it 1 unit right. So x minus 1 squared. And then what am I calling this? G. Okay, so I stretched by 3. And then I moved it 1 unit right. There's my function. Okay, the graph of h is a reflection in the x-axis followed by a translation 3 units left and 2 units up of the graph of f of x equals x squared. So I'm going to start with f of x equals x squared. I'm going to go in order. Okay, reflection in the x-axis, negative x squared. Okay, now what? 3 units left, negative. 3 units left, x plus 3 squared, and 2 units up, plus 2. Did I get it all? What are we calling this thing? H of x? There we go. Now let's try C. Okay, the graph of G is a vertical shrink by 1/3 and a translation 1 unit down, followed by a reflection of the x-axis of this function. So let's start with this thing. Okay, start off vertical shrink of 1/3. Ooh, okay, so I'm going to do 1/3 of this thing. Okay, 1/3. I don't distribute it because it's being squared, but 1/3 of 9 is 3. Let's go to the next one. 1 unit down. So I'm going to minus 1 here. So now I have 1/3 x plus 6 squared. 3 minus 1, now I'm at 2. Okay, now what? Reflection of the x-axis. So I need the whole thing to change signs. Okay, I think we're about to get, and that's going to be our result. Yep, g of x equals, let's make this look nicer. Negative 1/3 x plus 6 squared. Distribute the minus, minus 2. Okay, that one had a lot. Let's look at D. D has a star because it's going to be extra. Okay, the graph of H is a translation 3 units right and 2 units up of the graph f of x equals x squared plus 5. Let's start with 3 units right. Well, it's going to look weird though, because 3 units right is going to be x minus 3. But where do I put that? Well, I have to put it in both places it has the x. So it's going to go 3 units right. And this also goes 3 units right. Okay, I'm going to multiply this out. If I do x minus 3 times x minus 3, I get x squared minus 3x plus 9. Okay, so I have x squared minus 6x plus 9 plus 5x minus 15. Let's make this nicer. Minus 11x, 9 minus 15 minus 6. Okay, am I done? No, now we need to go 2 units up. So what do I do? Plus 2. Okay, so now what do I have? X squared minus 11x minus 4. And this graph is called h of x. Okay, so that's going to be my final graph. Okay, and that's if I graph this, which I don't actually know what it looks like, and I moved it 3 units right and 2 units up, I would end up with this graph.